Hi, Math 30s. We are moving on to Lesson 8 in your workbook, which is investigating the graphs of polynomial functions, and it's on page 337. Before we actually start looking at Lesson 8, I want to do a review of some concepts that we touched on in Lesson 7. And where I want you to write this is if you flip the page to page 336, you have some white space at the bottom of page 336. And so I just want you to write this odd degree and even degree, and then I will discuss it. So you could just pause the video, write that down. Once you have all this written down, you could unpause the video. Okay, so the first thing I need to discuss, make sure you understand, is what's an odd degree polynomial. So an odd degree polynomial would be a degree of 1, x to the 1, x to the 3, x to the 5, x to the 7. Those would all be odd degree polynomials. What you need to know is the end behavior of these polynomials. So if I give you an odd degree polynomial and the leading coefficient is positive, what happens is the left arm of the graph is going to fall and the right arm of the graph is going to rise. So for an example, a polynomial that's an odd degree with a positive leading coefficient would be something like p of x is equal to x cubed, and then I could say have some more terms there. But what this would look like, this polynomial, so this is an odd degree, and there's a 1 here. So it's an odd degree, positive leading coefficient. The left arm falls, and the right arm rises, okay? If I give you an odd degree polynomial, so p of x is equal to, let's do the third degree again, x to the 3, but I give you a negative leading coefficient. What happens with this polynomial, anytime you have a negative lead, and this is either a 1, a 3, a 5, or a 7, the left arm is going to rise, and the right arm is going to fall. So what this graph would look like, anytime we have an odd degree, negative leading coefficient, the left arm must rise and the right arm must fall. So our graph would look maybe something like this. Okay, so this would be an odd degree negative lead coefficient. This is the end behavior of the arms. You just have to know these end behaviors. Let's go through even degree. What's an even degree polynomial? X squared, x to the 4, x to the 6. Those are all examples of even degree polynomials. So if I give you an even degree polynomial and it has a positive leading coefficient, what will happen is both arms are going to rise. So for example, let's look at the graph of y is equal to x squared. This is an even degree polynomial. There's a 1 here, so that's a leading coefficient that's positive. The end behavior, I said, both arms must rise. So my graph would look something like that. If it is an even degree polynomial, so this is a 2, 4, or 6, but it has a negative lead coefficient, so let's say I gave you negative x to the 4, both arms fall, okay? So you need to know, again, the end behaviors of the arms. This takes students a while until they're like just able to see a graph and know what the end behavior is. This will be further reinforced when we do the class examples, as well as I'll be giving you the podcast to watch that's going to talk about end behavior of your polynomials versus if it's even or odd, positive lead versus negative lead. So you sort of have to know these 4 scenarios really well. Okay, let's start exploring lesson 8. So highlight this word repeated factors, and I'm going to explain what repeated factors are. This polynomial function here, they've given it to me in factored form, and it's always really nice when it's in factored form because you can easily look at the polynomial and tell me what the zeros are. What are the x-intercepts? So this factor here, x plus 1, that has an x-intercept of -1, which would be that guy right there. This factor here, x minus 3, has an x-intercept of x is equal to 3, which corresponds to that point right there. Now, what's different from this polynomial versus the polynomials we did in lesson 7 is this polynomial actually has a repeated factor, and the repeated factor is shown right here. So if I was to rewrite this polynomial, this would be p of x is equal to x plus 1. This x minus 3 occurs twice. So x minus 3 and x minus 3. Okay, so a couple of things. This right here, this x minus 3, it's a repeated factor. Okay, this polynomial though, if I said how many distinct zeros are there, how many x-intercepts are there, this polynomial, even though it has 3 factors, there's only 2 distinct x-intercepts. This is one distinct x-intercept, x is equal to -1, which will be right here, and this x-intercept the graph cuts through. The other distinct x-intercept, and it's just a repeated 0, is going to be x is equal to 3, right? So there's 2 distinct zeros. That's my other x-intercept right here. Now, when we have a repeated 0, we're going to have a different behavior at the x-intercept. If we have a 1 here, the graph is going to cut through. And then if we have either a 2, a 3, or a 4, we're going to have a different behavior. And in this example, it just touched. And we'll learn later on in this lesson when it will touch versus not touch. Okay, so again, there's 2 distinct zeros. And those 2 distinct zeros are x is equal to -1 and x is equal to 3. These are the factors. This x minus 3 is repeated, right? And the other factor was x minus 1. That one was not repeated. So the zeros of the function are x is equal to 3 and x is equal to -1. Okay, the x-intercept of -1 represents a real 0 of the function. And the x-intercept of 3, that we would say has 2 equal real zeros. And the reason why we say it has 2 equal real zeros is because this x is 3, that x is 3, they're 2 equal real zeros. But altogether, again, this is 1, 2 distinct zeros. Okay, so let's talk about something called multiplicity. So first of all, if I rewrote this polynomial function, so the one we just did, so p of x is equal to x plus 1, and then it was x minus 3 squared. Okay, you have to be able to state what multiplicities are. So the first thing, I always like putting a 1 here. And the reason why I do that is because you could easily now look at this and tell me what the degree of this polynomial function is. So the degree of this polynomial function is 2 plus 1, which is 3. So this is a 3rd degree polynomial function. It's odd. And the leading coefficient is positive. So you should be able to think about what we started at the beginning and said, well, what would the end behavior of this graph be, right? So if you looked back and you said, okay, odd, and it's positive, the end behavior, the left arm falls, and the right arm is going to rise. So you just have to know that. This gives you an x-intercept, or a 0, of -1. Okay, so this graph has a 0 of -1, and then I'll say, well, what's the multiplicity at that 0? The multiplicity at that 0 is going to be 1. This 0 here is a 0 of 3. So x is equal to 3, that's the x-intercept. It has a 0 of 3. The multiplicity of this 0 is 2. So multiplicity is 2. Okay, I'm going to give you some other examples so that you could see if you could understand this concept of multiplicity. So you've got some space right here. I want you to write just these 2 examples here. Okay, so take a minute, write that, and then we'll talk about what the zeros are and what the multiplicities are. All right, before we get into zeros and multiplicities, I'm just going to put my invisible 1 there, my invisible 1 here. This polynomial is a 3rd degree polynomial. this polynomial is a fourth degree polynomial. So third degree polynomial, that's odd, and the leading coefficient is positive. The left arm is going to fall, the right arm is going to rise. This polynomial is even because it's a fourth degree polynomial. So even degree polynomials where the leading coefficient is positive, both arms are going to rise. So this is sort of what I mean where we started, that you have to understand what the end behaviors of the graphs are. Okay, let's talk about multiplicities. This factor would give you a 0 of -1. So -1 is the 0 or the x-intercept of the graph. If I said what's the multiplicity of that 0, you would say the multiplicity of that 0 is 1. Okay? This factor has a 0 of 3. So the 0 is going to be 3. It's got an x-intercept of 3. The multiplicity of this 0 or this x-intercept is 2. If we did this example, this will give you a 0 or an x-intercept of -1. So the 0 is -1. The multiplicity is going to be 1. This factor here would give you a 0 or an x-intercept of -2, and the multiplicity is 3. So when we do the two class examples, it's going to be looking at polynomial functions, being able to pick out what the degree of the polynomial function is, what the zeros are, and what the multiplicities are. Okay, now we're going to look at the bottom of the page. Don't worry about writing this. We're going to look at the bottom of the page, which has the words tangent and point of inflection. So these two concepts are actually concepts from calculus, but I'm going to just show you and explain, because I'll be using these words in lots of the examples, what a tangent graph looks like versus what a graph with a point of inflection looks like. So the first thing is a graph that's tangent. So a graph that's tangent is going to have a multiplicity that's even. So a graph that's tangent, it's going to have factors where the multiplicity is even. Okay, so what tangent means is it means that your graph is going to approach the x-intercept. It's going to touch the x-intercept but not cross it. Okay, so the graph is going to come to our x-intercept. So let's say that x-intercept was at 5. It touches 5, so that is considered a 0, and then it does not cross. It goes back up. Point of inflection. So let's say again that this x-intercept was 5, or that on our x-axis that was 5. Point of inflection is where the graph comes up to our 0, it touches, and then it crosses the 0. And where we see this point of inflection, it's going to happen where our multiplicity is odd, not degree 1 though. Degree 1, so if we had this, for example, x minus 5, that's to the power of 1. This graph is going to just cut straight through at 5. But if I gave you y is equal to x minus 5 cubed, the 0 is 5, the multiplicity is 3, and if you have a multiplicity of 3 or a multiplicity of 5, what that means is we're going to have a point of inflection. And our graph, it's called, it changes concavity. So it goes from concave down to concave up. Okay, so you'll sort of, I'll talk about these terms in the next examples. Okay, so let's flip over to class example number 1. So go to page 338 and let's look at class example number 1. So it says, consider the polynomial function. It gives me this polynomial function in expanded form, and it gives me the polynomial function in factored form. So a few things that we're going to write down. We know from our previous lesson, lesson 7, this is the y-intercept of my graph. So when it is in expanded form, This guy right here is my y-intercept. So the y-intercept of this graph is or is equal to negative 24. This tells me the degree of my graph. This is a 6th degree polynomial function. What you need to be able to take from this is you need to be able to take, is this an odd or even polynomial? This would be an even polynomial. The leading coefficient, so there's an invisible 1 there, the leading coefficient is positive. You need to know what are the arms or the end behavior of a even degree polynomial with a positive leading coefficient, and the end behavior, the left arm and the right arm are going to rise. So it's just something like you have to memorize that. If it's even and positive, the left and the right arm are going to rise. Okay, they give me this polynomial in factored form. So in factored form, I could easily look at this and I could get the zeros of this, or the x-intercepts. So this x-intercept right here is x is equal to negative 3. So let's go to our chart and let's put in the 0 of negative 3. The multiplicity of that 0 is 1. If you have a multiplicity of 1, what is going to happen is your graph is going to just cut through the x-axis at that 0. So it's going to cut through at x is equal to negative 3. Okay, let's look at this factor, x plus 1 squared. So you just need to be able to look at that, and you need to be able to say what the x-intercept is. The x-intercept is going to be negative 1. So that gives me the graph is going to have a 0 at negative 1. What is the multiplicity? The multiplicity is 2. Remember that I said if you have an even multiplicity, so like a 2 or a 4, what's going to happen is your graph is going to be tangent. So the graph is tangent at x is equal to negative 1. And remember, tangent means that it's going to touch the graph at negative 1. So it's either going to look like that or it's going to look like this. So tangent means my graph is going to touch the x-axis at negative 1, but it's not going to cut it. So let's actually put these x-intercepts in. So negative 3 was one of my x-intercepts, and it's going to cut through that one. Then we had an x-intercept or a 0 at negative 1. This one's going to be tangent. Then the last x-intercept is going to be this guy right here. So x is equal to 2. So the 0 is 2. The multiplicity is 3. And remember from the previous page, you have to know like tangent versus point of inflection. So tangent is if you have a multiplicity of 2 or 4. Point of inflection is going to be you have a multiplicity of 3 or even 7. 3, 5, or 7. That would be a point of inflection if the multiplicity is that. So this graph is going to have a point of inflection. Okay, what does a point of inflection look like? So at 2, so let's put in our x-intercept of 2. The graph is either it's going to cut it, and it's going to change concavity. So it's either going to look like this, or it's going to look like this. Okay, so how we figure this out is we know that these are my x-intercepts. Okay, so I know that. The other thing I know is my y-intercept. So I'm going to put that on my graph, negative 24. So my graph has to go through this point here. And I know, so without even graphing this on my calculator, I know that the end behavior, we will graph it, but the end behavior has to be, the left arm must rise and the right arm must rise. So it's got to do this, and it's got to do this. Okay, so what happens is the graph at So let's see. At -3, it is going to just cut through it. Actually, let me just change that a bit. Okay, so at -3, it's going to cut through. I know that my graph then has to go through and it's got to be tangent at -1. So the graph's going to cut through -3, it's going to come back up, and at -1, it is not going to cross it, it is going to be tangent to it. So what that means, the graph is going to come up, touch it, come back down. That's going to be the y-intercept. And at this 0 here, there's going to be a point of inflection. It's kind of hard to do this, but it's going to look something. Okay, point of inflection, it has to change concavity. So we just have to have that weird thing here where it changes concavity. So this is sort of what the graph would look like. You will always be able to graph these to double check. So let's punch this into our calculator. So let's punch in the graph in factored form. And this tells you, what this is telling you here is it's saying it wants you to set your window, your x minimum to be -5, your x maximum to be 5, and your scale factor to be 1. So take out your calculators, and in y is equal to, get your polynomial function entered. So x plus 3, x plus 1 squared, x minus 2 cubed. From there, go to your window. It says it wants you to change your x minimum to be -5, maximum to be 5, scale factor to be 1. It wants you to change your y minimum to -100, y maximum to 100, and then it said your scale factor for the y, it wants to be 20. So minimum, maximum, scale factor. Hit enter on your calculator, or sorry, hit graph, and it will give you this graph here. So this is your x-intercept at -3, it cuts through. This was -1, it is tangent. This is going to be our y-intercept. Let's check what that is. Second function, calculate a value. When x is 0, y is -24. This is another x-intercept, so 3 distinct zeros, right? There's 3 of them. And this x-intercept, it was the one that had the multiplicity of 3. So this is the one where it like comes up, does that weird curve, and then continues. The end behavior of my graph, you put an arrowhead here, and you would put an arrowhead here, okay? So complete the following. The degree of this polynomial function is, again, I could get my degree from here, which is a 6th degree, or I could add up 1 plus 2 plus 3, which gives me 6. The sum of all the multiplicities of the zeros is going to equal the degree. So 1 plus 2 plus 3 is equal to 6. Okay, let's do class example 2. So last class example, then I'll give you some practice. What we have here is we have a 4th degree polynomial function. Okay, so let's say this is a degree 4. And there's a 1 here, so the leading coefficient is positive. So what you need to be able to see from this is that this is an even degree, positive lead coefficient. If you have an even degree positive lead coefficient, what you just have to know is the end behavior. The left arm is going to rise and the right arm is going to rise. Without even seeing your graph, you need to be able to visualize that. Okay, we're going to punch this into our calculator and we're going to change our window. So they want x min, x max scale, y min, y max scale. So let's take our calculators out. Let's clear this, and it's not factored, it's an expanded form. So let's write that function in. So it was x to the power of 4 plus 2x cubed minus 15x squared squared minus 32x minus 16. There's my y-intercept at negative 16. Let's change our window. They wanted the x-min to be negative 6, x-max to be 6, scale factor to be 1. They wanted my y-minimum to be negative 150, my y-maximum to be 150, and my scale to be 20. Let's graph this. Okay, so look at that. There is my end behavior of this graph. Here I could see my zeros. This is a fourth degree polynomial function. And let's figure out what the zeros are. So on your calculator, go to second function table. And looking at the graph, first of all, there should be 1, 2, 3 zeros. Okay, so there should be 3 zeros. So second function table, there should be 3 of them. There it is. So there's a 0, there's a 0, and there's a 0. So my x-intercepts, or my zeros, are negative 4, negative 1, and 4. Okay. So let's write my x-intercepts or my zeros. So x is equal to negative 4. That would give me a 0 at negative 4. The next x-intercept from that table was x is equal to negative 1. And that gives me a 0 of, negative 1. And the last x-intercept, it said x was equal to 4 was a 0. So there's my 3 zeros at negative 4, negative 1, and 4. So let's put those zeros in. 1, 2, 3, 4. 1, 2, 3, 4. I know that I have a 0 here. I know that I have a 0 at negative 1. And I know I have a 0 here. Now I'm going to get the picture right from my graph again. So let's get the graph. Okay, so it's going to fall. It's going to cut through. Here is tangent. And this one, it's no point of inflection. It's going to cut through again. So the only thing that you need to recognize is this one cuts through, this one's tangent, this one cuts through. So let's see if we could draw this. So what this would be, my graph is going to cut through this. It's tangent to this, and it's going to cut through this. This is my y-intercept, which is negative 16. So that guy there would be negative 16. I'm just going to put my zeros in. This one was negative 4, this one was negative 1, and this one was, what 0? That was 4. Okay, so once you have your graph and your picture, you should then be able to figure out what the multiplicities are. If it cuts through, you have a multiplicity of 1. So I've got a multiplicity of 1 there. It cuts through here. I've got a multiplicity of 1 there. Here it is tangent. So tangent is going to be a multiplicity of 2 or 4 could be tangent. But if I know that this is a fourth degree polynomial, this is adding up to 2 already. So the multiplicity of this guy must be 2. Okay? The description would be cuts through at negative 4. So cuts through x is equal to negative 4. If I said, what is the factor? The factor would be x plus 4 would be my factor, and there would have to be a 1 there. I don't need to put that invisible 1 though, okay? Multiplicity of 2. What's the description? The description is tangent at x is equal to negative 1. So tangent at x is equal to negative 1. what that factor would be, the factor would be x plus 1, and I know that the multiplicity is 2. This 0 here cuts through x is equal to negative, or sorry, x is equal to 4. The factor would be x minus 4. And I know that the multiplicity is 1. When it cuts through, the multiplicity is always going to be 1. Okay, the degree of this polynomial function is, that tells me the degree. It's a 4th degree polynomial function. The sum of the multiplicities must add up to the degree. So the degree of this, or sorry, the sum of the multiplicities is going to be 4. Write the polynomial function in the form of p of x is equal to. So basically wants this in factored form. And what it wants is it wants my 2 multiplicities of 1 to be first, and then it wants that multiplicity of 2 to be here. So I would say p of x is equal to, this was a multiplicity of 1, so I'm going to say x plus 4. This guy was a multiplicity of 1, so that's x minus 4. And followed by, this was a multiplicity of 2, that would be x plus 1 squared. Okay, if you were to plug this into y2, you would get this exact same graph that would just cut right over top of the equation that is written in expanded form. So that's the end of this lesson, lesson 8. And the homework for this lesson is on page 339. And I want you to do these questions here. So questions 1 to 3, 7 to 10, 12, and 13.